Now you might be looking at the title of the video and thinking, oh, he's being facetious. He's joking about. There's no way this question's easy. It's got too many words in it to be easy. It's a nonlinear first order differential equation. There's no way that's easy. There's too many words. Relax. It's easy. Take a deep breath. Okay, meditate. Open up your Calm app. Buy the premium subscription. Okay? We're going to walk ourselves through it. I'm currently using the Mathematics for Economics textbook. It's one of my favorite textbooks ever. So I got a little bit carried away and I didn't talk about what I was doing the whole time I was doing it. I was just kind of pointing little schizo arrows everywhere, and then, just came to realize I was just doing it and I wasn't talking about it, so we're going to talk about it. All right. Essentially, you write down the information that's given to you. This was just in the textbook. You need to set this right here to 0. This is a dot. This is a dot. When you're doing nonlinear first order differential equations, you want to find your steady state. Okay, you don't want to be moving around. You don't want to be going crazy. All right, but unfortunately, we're gonna be getting a little crazy because it takes us time to adjust our output. So there's a little bit of a lag, but we want to get to a stable point. We just want to know if that point is actually stable. So this is why we're doing this. We're setting this to 0 first, and then you're solving for Q hats. This becomes Q hat. This is your steady state, or hope to be steady state. It might not be steady. There's some conditions that have to be met. So you set this to 0, and then you solve for this Q hat. And it becomes very apparent this is the answer. And to double check, I deleted all of it, but to double check, you can reinsert this solution you have here back into this Q hat here. And then you should be able to just get 0. You need to get 0 here. But the Q hat is larger than 0, and that's part of the constraint, that's part of the satisfaction, finding out, you're drawing the phase diagram. We're at the end, and you can essentially, if these two things, well, I'm getting ahead of myself, so I gotta chill. You're doing little derivative moment here just to figure out if it's negative or if it's positive. Here it's negative, which is also what we want to see. So how are we getting this? It's just this. I just factored in the alpha. That's just what I did there. And it's just a very easy derivative. That's what you got here. Obviously, that's less than 0. It's negative. Alpha is greater than 0. And so because this derivative here is less than 0, at any q greater than 0, including this q hat, we are stable. We have a stable point. And this is what the phase diagram looks like just down here. This is a steady state. John Nashville.